So today we will discuss about the block diagram reduction methods. Okay, yesterday we have discussed that for your external examinations, you will get 2 questions from the first unit. Okay, so from the first unit lo nunchi meeku 2 questions you may expect. Okay, so from the second unit again you may get 2 questions. Okay, so from the third unit also you may get 2 questions. Okay, from the fourth unit you may get 1 question, and from the fifth unit you may get 1 question. Okay, so this is the pattern you may have in your external examination. So in the last class we have discussed about the closed loop and open loop systems and the type of different systems, and then mathematical modeling. Okay, so you may expect any question from this, and also from the open loop and closed loop systems and the mathematical modeling transfer function. Okay, and also the mathematical modeling of your armature control. Okay, I'm not going to deal here now. So armature controlled DC servo motor and field control. Okay, field controlled DC servo motors. You may expect question from this also. So the possibilities are you may get another question from block diagram, reduction method, or signal flow graph. Okay, so this may be bit A, this may be bit B. Okay, so similarly A or B, like that you may expect any question on these topics. So just you completely thorough in this block diagram and signal flow graphs, so you can answer easily the question. And if you study the mathematical modeling of the mechanical, translational, and rotational systems for finding the transfer function, and also writing the force voltage, force current, or torque voltage, torque current analogous circuits. Okay, this is the these are the expected questions from the first unit. Okay, so today we will discuss about the block diagrams and signal flow graphs from the first unit. Okay, so for any system, this G is the forward transfer function, and H is the feedback transfer function. GH is the open loop transfer function, or it can be called as a loop transfer function. And from this, you can estimate the closed loop transfer function, which is given by C by R is equal to G by 1 plus or minus G of S. So it depends on your feedback. Okay. And E by R is the actual error ratio. So this is given by 1 by 1 plus G of S into H of S, or GH. Okay, or your primary feedback ratio is GH by 1 plus GH into 1 plus or minus GH. So these are the ratios which you can find out from any given feedback control system which is in a canonical form. Okay, so this is the characteristic equation here. This one, the denominator of your characteristic closed loop transfer function is known as the characteristic equation. So this is the 1 plus G of S into H of S is equal to 0. It is nothing but the characteristic equation. And from this you can find out the open loop transfer function. This is not required here. I'm not going in detail. So these are the different methods, reduction methods. It is very, very important. Okay. So the first is a combining of blocks, which is a G1, G2, which two are in cascade form. So the resultant is going to be G1 plus G2. Okay, so here the input is R and your output is C normally will take. So this is again R and C. And the second resistance technique is when the blocks are connected in parallel. So this is your R and this is C. So the resultant of these two elements which are in a forward direction which are connected as a parallel. So it is equal to G1 plus G2. As you know all these things, just for the just now the moving of summing point behind the block. So here the summing block is in before the block. Okay, now I need to move this block to ahead of the block. So in this process you have to add G. Okay, so here the input is C and your output is C. Okay, and you're adding only one particular A. Okay, so your output C is going to be R minus A. Okay, so because R is coming here minus A, so R minus A into G. This is your output, and whenever you are moving shifting this also you have to get the same value, and that's why here you are getting R into G. Then if this is a signal A, G into A you are adding, so this is the AG, so you will get RG minus AG. So it should be adding with this G. And then if you want to move the summing point to before the block, then it should be represented as 1 by G. Okay, and then pick off point. So I need to move this pick off point to ahead of the block. So it should be represented or replaced with a block of 1 by G, and moving again a pick off point to the before the block. So you need to multiply this with G. So this is a technique which we need to use while reducing your block diagrams. And this is an important the eliminating the block. So here if this is a plus or minus, okay, now this is going to be 1 minus r plus, this is on the here, this is the minus r plus gh. Okay, so the signal is R, this is C. Again, you will convert this into G by 1 minus R plus. So if the feedback is plus, you're going to get it as a negative. Okay, so this is going to be G divided by 1 minus R plus G into H. Okay, so here the feedback is 1. So you'll get this as a minus R plus 1 G by 1 minus R plus into G. So this is the way of eliminating all the blocks for the reduction. Okay. Now here the swapping of two neighboring sum of, so there is no change. So easily you can directly change it because you are going to get the same values. Okay. So directly you can change it. And here I will solve this problem. So reduce the block diagram into canonical form. So if you observe this, G1 and G4 are connected in cascade. So the resultant of these two will be your G1 into G4. And next, these two are connected in parallel because this is coming in this direction and this is also here. So these two are meeting at this summing point. So these two are in parallel. Okay, so the resultant of these two is nothing but your G2 plus G3. Okay, so step one, we need to write the step one. The step one is eliminating the cascaded blocks and also eliminating the parallel blocks. Okay, so as per rule one, I can eliminate or this combine these two into one block, that is a G1 G4, and these two are in the second path. This can be represented as G2 plus G4. So are you writing the notes? Shall I wait for some time, or can I go faster? Yes, please respond. So I'm going very faster. So if you want to write this in notes, just I will go somewhat slower.
Continue, sir.
Anyone? Yes? Continue, Chena? Next. Now, so here, these two, I'm clubbing into one block, which is a G1, G4, and these two are connected as G2 plus G3. Okay? Next. Now, as if you observe this block, the first block here, it is looks like a feedback path. So this is a feedback loop. Okay, this is a loop because your H1 is coming from the G1 G after G1 G4 block, and it is added to the summing point here. And therefore, these two are forming the loop. So the resultant value, the resultant of these two will be, as per our formula, G divided by 1 minus, because your feedback is a positive, so this should be taken as negative, into G1 G4 into H1. So this is the resultant of this particular block. Okay, so I will eliminate the feedback loop. The step 3 is eliminate the minor feedback loop, which is G1 G4 divided by feedback loop is H1. So the resultant value is G1 G4 by 1 minus G1 G4 into H4. And the next one is, here I am representing this value as this block. Okay, so when you represent this, and this complete block and this block both are in cascade. Okay, so this one, so first one is eliminated as uh, this one, and next one is G2 plus G4. So these two are in cascade, and therefore the resultant value will be now G1 G4 into G2 plus G3. Okay, so this is the resultant of these two blocks, and therefore you can write up this as G1 G4 into G2 plus G3 divided by 1 minus of G1 G4 H1. Okay, and now this is, you can assume this as a G, and this is a H, and this is a feedback loop. Okay, so this resultant value will be given as G by G by 1 plus GH. Okay, because here the feedback is negative, therefore this value is going to be, so here G is equal to this block and H is equal to H2. So we need to write up the complete block here. So here it is not there. So just you substitute in this block, then you will get the original block. Okay, so this is going to be G1 G4 into G2 plus G3 divided by 1 minus again G1 G4 into G2 plus G3 divided by 1 minus G1 G4 H1 into H2. Okay, so this is the value. Now you can convert this into here. Okay, then after that you bring this to numerator value. So that will give you the total block diagram, single block diagram. It is converted into single block. Okay, so this is the way of writing. You are reducing the block diagrams into a single block. Okay, so example 5. So here we'll solve this one. So if you observe this, first of all, we cannot directly convert or find out any cascaded paths or parallel paths or single feedback loops here. So we need to move this point here. Okay, so the first of all we need to find out which point should be moved and where it should be moved so that you can easily solve. Okay, so this is a takeoff point, and this takeoff point I will move to here. Okay, so when I move this takeoff point to here at this point, okay, so you can observe that these two may be connected in cascade. So you'll get a G2 and G3. These two are in cascade. Then after that, you may say that this path, okay, so this path will be a closed path. So you can reduce this into a single path. Then after that, your G1 is going to be cascaded with this. Okay, so here, this is like this. Now if you remove this one only, then this complete path will be G and it is a closed path. Like that, you can easily solve it. Okay, so the first step is very, very important when you are choosing the reduction of your blocks. Okay, so what is the first step now? So instead of doing, they are doing, there is another way of doing this, which is just interchanging the summing point before the block. Now these two are in cascade, so you'll get a G1, G2. Okay, then after that, just interchanging the summing points. Here you see, this is these two summing points are interchanged. So this path will become the loop. So you can eliminate this, which is G1, G2 by 1 minus G1, G2 into H1. And next, these two are in cascade. So you can club into one block. And next, yeah, just you see, this is a G and this is H. This is a closed path it is forming. So G by 1 plus G1, G2, G1, H2. So you will get this block. And here H is equal to 1. Again, this is a feedback loop. Okay. So again, you'll get the complete block as again you have to do the calculation here, which is nothing but G1, G2, G3 divided by 1 minus G1. Sorry. Okay, 1 minus G1, G2, H1 plus G2, G3, H2 divided by 1 minus of this total value again. Okay, so that is G1, G2, G3 divided by 1 minus G1, G2, H1 plus G2, G3, H2 into H1. This is 1. Okay, this value is going to be 1. Okay, so the denominator values will be cancelled out. So your transfer function is going to be G1, G2, G3 divided by this total value is coming here. So the value is going to be 1 minus G1, G2, H1 plus G2, G3, H2 minus G1, G2, G3. So this is your complete block diagram with the input of R, and the output of C. Okay, so you can also solve this problem by using your signal flow graph analysis. What we see that here, this is a node, this is another node. Here we can consider this as a node, and this is another node with a G1. Okay, and this one is again another node with a 1. Next G2, G3, and your output. So like this, we need to write up, we need to draw the signal flow graph. Okay, so directly you can get the transfer function. Okay, so after finishing this block diagram method, we'll go through this signal flow graphs again. Okay. Should we solve one more problem?
Yes,
Okay,
sir.
just note down this. Just try to do this. So for this, just note చేసుకుంటున్నారా?
Yes, sir.
Just note చేసుకున్నాను. ప్రాబ్లం ట్రై చేయండి. మీరు ఇక్కడ ప్రాక్టీస్ చేయండి. ప్రాక్టీస్ చేస్తే ఇంకేదైనా డౌట్స్ ఉంటే నేను అడగండి. సో ఇక్కడ ఏం చేయాలి మనం? So how to reduce this? We need to change this. Okay. So this block, this line, or this block H1 line has to be moved. Okay. Just to see. ఒక్క నిమిషం లైన్ లో ఉంటారా? Hello? Hello? Hello?
Yes, sir.
వినిపిస్తుందా? ఒక ఇంపార్టెంట్ కాల్ వచ్చింది, అందుకనే కట్ అయింది.
Yes, sir. Visible.
ఓకే, కనిపిస్తుందా? వినిపిస్తుందా?
Yes, sir. Condition. Yes, sir.
ఓకే. So here we need to change this point. Okay, so we need to move the pick off or cut off point to point B before the block G2. Okay, so A నుంచి B కి మనం మూవ్ చేయాలి. Okay, so whenever you are moving this, you are losing here the value of gain G2, because here after that you are taking the G2 value, but when you move to the before the block here, you are losing the G2. That's why we are adding an extra G2. Okay, so once you move this, now simply you can eliminate these two blocks, which are G2, G3, which are in cascade connection, and G4 is connected to the summing point. Okay, so the resultant value is going to be G2 into G3 plus G4. G2 into G3 plus G4. This is the resultant value. So you can eliminate that as a G4 plus G2, G3. Okay, so here that block will be eliminated as G4 plus G2, G3. Okay, and next we need to move the pick off point behind the block. So that means here this block has to be moved to here. Okay, so that from this point to this point. Okay, so your value here, this block, this line will be eliminated here. Okay, so this is shifted to this point, but whenever you are shifting this, you are adding extra this value G4 plus G2 into G3. This value you are adding whenever you are moving this point to here, and because of this we need to divide this. We need to divide this block, and then this signal will be like this. Okay, so this is a feedback link which is coming forward from this point C. Okay, and therefore you can now, as this line is eliminated, now these two will form the loop. G4 plus G2, G3, H2 will form a loop. Okay, so we need to eliminate this loop, and this loop can be eliminated as like this: G4 plus G2, G3 by 1 plus H2 into G4 plus G2, G3. Okay, so as this is eliminated again, now this G1 and this block are cascaded. They are in cascade, and therefore you can eliminate this as G1. Okay, so G1, this total value is going to be G1, so you can eliminate now. And this block is G and this block is H, because this is in a reverse block. Okay, so these two will form again loop. These two are forming a loop, so you can eliminate this as G by 1 plus GH. So the resultant value is going to be this. Okay, so G1 into 1 plus G2 G3 divided by this G4 G2 by G1 H1. So this G2 H3 will be cancelled out here. So 1 plus G1 G2 H1 plus H2 into G4 plus H2 H3. Okay. Then again you need to reduce this into single block diagram. Okay, so single block by taking this as a G and here H is equal to 1. So this is going to be your R of S and this is going to be your C of S. Okay, so this is a value now. Okay, so this is the resultant of your given block diagram. This is Y of S by R of S. Is it clear? Is any doubts on this? Okay, just you can also take this. Just you try to find out this. Okay, so here first of all we can eliminate directly G2H2. Okay, so this is going to be G2 by 1 plus G2H2. Okay, then you can take this point here, point A to point B. So directly you can divide this because your signal here A is included with only G1, but when you move this point to point B, okay, so you are included this particular block. So this block has to be divided here. Okay, so 1 by G2 by 1 plus G2. So just you reverse it 1 plus G2 by H2. Okay, so now these two are in cascade. So G1 G2 by 1 plus G2 H2. And next, the second one is in parallel because this is a summing point. So the same loops are in parallel. You have to add these two points. Okay, so this is not a feedback loop. This is a parallel path. Okay, so the result of this is H3 plus H1 into this two are cascaded. H1 and this block both are in cascade. So you directly you have to multiply this with H1. So H1 into 1 plus G2 H2 by G2. Okay, so now eliminate this loop. You will get this block as like this. Now this is completely a closed loop. So you consider this as G, now H. So the formula is again G by 1 plus GH. So you will get the final transfer function as like this. Is it clear? So now shall I close this? Well, shall we start a signal flow graph? So if you want solve all these problems, I will give you the PDF of this. So you can go through all these things. Okay, so this is a block diagram of a armature controlled motor. Okay, so this is also a DC servo motor. So armature will have this circuit equation of this one. Okay, so VA is equal to this VA of S. VA of S is equal to RA plus LA. Okay, so normally we'll write this as a VA is equal to RA IA plus LA into DIA by dt plus back EMF. Okay, by using the Laplace transform approach, you can directly write it as VA of S is equal to RA into IA of S plus LA S into IA of S plus EB of S. Okay, so this is your armature voltage equation, and as you know that EB of S is equal to some constant value KB into omega of S. Okay, so because your back EMF is proportional to the flux and the speed. As per your DC motor equation, EB is equal to pi Z and P divided by 60A. So out of this, only the flux and speed are variable points, but your flux is also maintained constant. Okay, flux is Shin motor as the flux is constant, therefore your EB is proportional to speed only. So, or you can take it as in terms of angular velocity, which is nothing but 2 pi n by 60. Omega is equal to 2 pi n by 60, and therefore you can write it as a EB is proportional to omega, or this is proportional. Proportionality constant can be taken as KB, okay, into omega of S. So that's why we are representing it as a AB of S. And as for if you come into the mechanical system now, so for the mechanical system, the torque developed will be equal to the moment of inertia into d square theta by dt square. Okay, d square theta by dt square plus some dashpot is there, which is nothing but d theta by dt. And therefore, you have representing this as it this omega is equal to d theta by dt. And therefore, your torque equation is going to be J into d omega by dt plus b into omega. Again, if you apply the Laplace transforms, this equation is going to be t of s is equal to j s d by dt is nothing but s into omega of s plus b into omega of s. B into omega of s. So here this constant k term is nothing but b. Okay. So your torque again as for the DC motor and also for the DC motors, your torque T is nothing but TA of S is equal to flux into IA, and your flux is maintained constant, and therefore your torque TA is proportional to IA. Okay, and this proportionality constant we are calling it as a KMA into IA of S, and that's why this equation is represented like this. Okay, so this equation is represented here. So T of S is equal to this one. T of S is equal to JS. So this one is J into S plus B into omega of S. Okay, so this equation we are writing here. So the first equation is your voltage equation. Okay, and the second equation is nothing but your EB equation. Okay, so EB KB into A, and the third equation what you have to take is TA. This is the third equation, and the fourth equation is this one. By using these four equations, you can easily represent your find the transfer function of a armature controlled DC motor, and also you can easily represent it in a block diagram reduction form. Okay, So this is your block diagram for the first equation. The first equation is VA of S. This is your input, and your output is having IA of S and omega of S. There are two different inputs here. So IA of S is your output. So here IA of S output I am taking here, and then the denominator, this value is going to be 1 by LA, or directly you can take it as a 1 by LA into S plus RA. Okay, so we need to add up this back EMF. So just you are adding here. Okay, so your output equation IA of S will be equal to VA of S, okay, minus kV into omega of S. Okay, so this is your input signal divided by this one, LA into S plus RA. This is your output. Okay, so this signal here, this is nothing but kV into VA of S minus kV into omega of S. Okay, and this is divided. Here we are taking a LA common, so this is going to be LA by RA. That's why we are representing this value like this. So this is the block diagram for the first equation. And once you get this, now we need to write up omega of S. So this is your output equation. So omega of S is equal to Km into Kma into Ia of S divided by Js plus B. Normally you represent this as a B. So this is going to be B. Your input Ia of S is there. So it should be multiplied with Km. Okay. And the output is nothing but your torque. Okay. So if this is divided by Js plus B, so if I take J common outside, so J is going to be B by J. So this is B by J. Then your output will be omega of S. And the next one is the resultant one. So this is with the first equation, and this is with your second equation. Now we need omega of S for the first block diagram, which should be taken from the omega S, which is taken here. Okay, so just you combine this. This is IA of S. This will be directly combined. So this is the block diagram of a armature controlled DC motor. Okay. So similarly, you can write off for the represent the field controlled DC motor block diagram. Okay. So where you will get only VA of S. There is no back closed path here. Okay. So here you will get all the terms in terms of the field winding. Okay, so these values are going to be field winding for field controlled DC motor where your armature voltage is constant. Okay, and this voltage is going to be VF of S, and these values will be 1 by LF divided by S plus RF by LF, and the same KMA is uh, available here, and this equation is also same, but this is not there. Okay, so the field controlled DC motor is a open loop system, and your armature controlled DC motor is a closed loop system. So because of this reason, for the controlling of load, normally we go for the closed loop control. So we required a armature controlled DC motor. Okay, just you go through the constructional details of DC servo motors, because the constructional details of DC motor you know very well, but just you go through the constructional details and the characteristics of DC servo motors and AC servo motors. You may expect any question on this. Okay, for with the theory as well as the development of this block diagram for any one of the methods. So this is also a very important question you may expect in your external examinations. So it is very easy to write up. Just you concentrate on writing the theory for DC and AC servo motors. Okay. Any doubts on this? If you have any doubts, then I will go again. Okay. So if you don't have any doubts, now we will go through the signal flow graph approach. This is also very, very important. So I will just give you the basic introduction about this signal flow graph, how it will be represented. Okay, so here this x1 is the input node, okay, and x4 is the output node, and one path. It is a continuous and a unidirectional succession of branches along which no node is passed more than once. So that means when you start from this point x1 and you move on to x4 from the input node to the output node only once. Okay, so you have to move from the x1, start from the node input node and reach the output node only once. Okay, you should not traverse the same node twice. So that is called as a forward path. Okay, so one forward path is from x1, x2, x3 and x4. So this is given like this. And there is another forward path which is known as x1, x2, x4. Okay, and next here there is also another path. So x2 to x4. This is only a path. It is not a forward path. So whenever you are going to see the forward path, you should start from x1, that is the input node, and you should reach the output node. So this is only a path, okay, but it is not the forward path. So whenever you are going for the signal flow graph approach, you should see that it should be a forward path. Okay, so here we have seen that there are three different paths, but out of this, only two forward paths are there. That is one x1 to x2, x3 to x4, and another one is from x1 to x2. Okay, and then here this one x2 to x4. And next, there is a feedback loop. Whenever you start from a point or node and you traverse in the forward direction and you come back to the same node. Okay, so that is called as a loop. So here, this is one loop. You're moving from x2 to x3 with a gain of a32 and you're coming back to x2. So this is one loop. Okay, and then there is a signal single loop, so which is nothing but a33. A33 is the self loop. It is called as, this one is called as self loop. So x3, it is starting from x3 and moving towards x3 only. Okay, and the next important thing is a gain. So gain is nothing but the value of that particular branch. Okay, a21 or a32. Here this is a23. So these are called as the gains. And then we need to find the forward path gain. So forward path gain is nothing but when you are moving from the uh, path from the x1 to x4, just you calculate the gains. So a21, okay, a32 and a43. This one, a21, a32 and a43. This is your path gain. Okay, for the first path. And from when you are moving from the x1 to x2 and then x2 to x4, so it is having a path gain of a21, okay, and a42. Okay, and next one is the loop gain. loop gain. So whenever you are taking a loop, so here this is a loop, this here, this one. Okay, so the gain is A32 and A23. So in this way you have to find the loops. And then next we should see that how many two loops are there, and these two loops are not touching or not. These two loops are touching to each other or not, we have to see that. Okay, so here this is a loop 1 and this is the second one, loop 2. So these two are touching to each other. Okay, so these two will not be called as a non-touching loops. Okay, so just we will see this. Okay, so how many forward paths are there for this circuit? So this is a forward path G1, G2, G3, G4, G5, and G7. This is the first forward path, and the next one is G1, G2, G3. Yeah, G3, G4, G6, and G7. This is another forward path gain. So whenever you are solving the signal flow path, so the first thing we have to take is the forward path gains. Forward path gains we have to consider. Then is there any other possibility of paths? So this is a loop, this is loop, and this is also loop. So there is no scope of forward paths. Okay, so this problem is having only two forward paths. And next, we need to see loops. Okay, so how many loops are there? We need to check up. So this is a loop L1. L1 is nothing but a G2 H1. G2 of S into H1. This is a loop L1 we'll consider. Okay, then what is the second loop? Just you see this here. Okay, so G4 H2. So you are starting from this point and moving towards another node, then coming back. So this is a loop. And next, third loop. Third loop is again you are starting from G4. Okay, so this is a node V3, V2, V1, and then you are coming back to V3. So this is another loop. And next, this again another loop is G4, G6, and then your H3. Okay, so this is another loop. So we need to find out these loops L1, L2, L3, L4. There are four loops. Then after getting this, we need to see that how many non-touching loops are there. How many non-touching loops? So that means here loop L1, this L1 is not touching to L2. So one possibility is there, that is L1 and L2. So these are the two non-touching loops. Okay, and the second possibility is again L1, L3. Just you see L1, L3, and these two are also not touching to each other. And the third possibility is L1 and L4. So L1, L4 is also not touching to each other. After that, we need to check these two again, L2, L3. After verifying with L1, we need to check for L2. So L2, L3 is touching to each other or not? So here L2 and this L3. So both are touching to each other. So we should not consider that. And L2 and L4 again consider. And they are touching to each other. And similarly L3, L4 also touching to each other. And therefore only the two non-touching possibilities are these three only. Okay. So here we need to take these three two non-touching loops. And after that, we need to take three non-touching loops. Three non-touching loops. So if there is any possibility, that is L1, L2, L3, L4. Okay, by seeing all these things, there is no possibility of uh, 3 non-touching loops. Okay, so we'll stop here only. Okay, so this is a way of finding the forward paths and non-touching loops. Okay, so for this problem, if you observe, input node x1 and output node is x8, and next forward paths. So forward path is from x1 to x8, and the second forward path is from x1, x2, and x7 and x8. So these are the two possibilities of forward paths. And next, another forward path is from x1 to x2, then x4, again x5, 6, 7, and 8. So there are three possibilities of forward paths. And next, we need to check up loops. So how many loops are there? Just you try to find out. So the first loop is here, then second, third, fourth, fifth, then self loop, the next one. This is also a loop. Next, x5 to x6, x6 to 7, then 7 to again x5. This is also another loop. Next, you can observe that this is also another loop. Just like that, we need to find out when you are going for the signal flow graph method, we need to find out all possible loops. And next, there is also another loop here. So like that, you have to see all the loops. Okay. And the self loop. Then these are the loop gains. All the loop gains. Okay, so these are the path gains. So with the help of all this introduction part, then we need to go for the Mason's gain formula or Mason's rule. Okay, this is developed by the S.J. Mason. Okay, so this is used to find out the final transfer function of any system. So this rule is defined as this one. So make exam లో వస్తుంది compulsory. What is the explain Mason's rule? Okay, దాని తర్వాత problem ఉంటుంది. So just you note on this. So the transfer function of any system is given by C of S by R of S. Okay, so this is equal to summation of I is equal to 1 to n pi into delta I by delta, where n is the number of forward paths. Here I is equal to 1 to n. So n is nothing but the number of forward paths. Okay, so just we have seen how to find the forward paths. And then pi is the forward path gain. Forward path gain. So if you're taking x1, x2, x3 up to x8, then the gain of that particular path we need to consider. That is nothing but your forward path gain. And delta is the determinant of the system. We'll see what is determinant. And then delta I is the determinant of the ith forward path. Okay, so delta I. And then this delta is called the signal flow graph determinant or characteristic function. Okay, which is equal to 0. Make it to 0, then it is going to be the characteristic equation. Okay, and then this delta can be obtained as this delta will be equal to now 1 minus sum of all individual loop gains. Sum of all individual loop gains. Just we have found that L1, L2, L3, L4. Okay, so we need to add up like this. So 1 minus L1 plus L2 plus L3 plus L4. So we need to write this sum of all individual loop gains. Okay, this is a 1 minus. Just you remember 1 minus of sum of all individual loop gains plus sum of the products of gains of all possible two loops that do not touch each other. Okay, so here we found out that L1, L2, this is a product of two gains of all possible loops which are not touching to each other, and therefore we have taken that this is L1, L2 plus L1, L3 plus L1, L4. So these are the three possibilities of two non-touching loop. So for the previous problem what we have discussed. Okay, so then after finding this, then minus the sum of the products of all the gains of all possible three non-touching loops. So that means you have to take here products of L1, L2, L3 or L1, L2, L4 or L2, L3, L4. These are the three possibilities of three non-touching loops. But for our problem, these all are zero. There is no non-touching loop is there. Three non-touching loops are available, and therefore we should stop the problem here only. Okay, after finding the delta, then next what we have to take is delta I. So from these values only we need to take up these values. So delta I is nothing but the value of delta for that part of the block diagram or signal flow graph that does not touch the ith forward path. So if you take up, this is a forward path which is in this direction here. This is a 2G 5 1 like this. Okay, then this is your loop. This is 5 or some H, let us assume. Okay, and there is another signal like this. This is your G2 and this is G1. Okay, so here this is a forward path. One forward path is from this point to this point, and the next forward path is here, this like this. So for this forward path, this loop is not touching. Okay, so this loop is not touching to this forward path. So that value has to be put in the delta I diagram. Okay, we'll solve all this again. Is it clear? This is a Mason's gain formula or Mason's rule. So whenever you are solving for the problem using the Mason's gain formula, so first thing we have to take is the first step is the calculate the forward path gain Pi. So I is the number of forward paths. Okay, and then after finding the forward path gains, we need to calculate the all loop transfer functions or loop gains, all possible loop gains. Then after that, consider the two non-touching loops at a time. Okay, if you are having a L1, L2, L3, L4, so we are writing it as a L1, L2, L1, L3, L1, L4 like this. So this is your next step. And after that, you consider the three non-touching loops, which are nothing but L1, L2, L3, L1, L3, L4 like that. And so on, you have to move on to the maximum possibilities. And after that, we need to calculate the delta with the help of these all loops. Okay. Then after getting the delta, then we need to go for the delta I in that which part is not touching to the forward path. Okay. So this is a procedure to be followed to find the transfer function using signal flow graph method. Okay. So for this problem, just we use this signal flow graph method to solve the transfer function. Okay. So for this, how many forward paths are there? So how many forward paths are available here?
Two, sir.
Nice, two. Okay. One is G1, G2 here, 1, G1, G4, G2, 1 and 1. Okay. And the next one is G1, G2, G3 like this. Yeah, sorry, G1, G4, G3. Okay. So these are the two forward paths. And therefore, we'll have a transfer function of C by R is equal to P1 delta 1. So this is a summation of I is equal to 1 to 2. So Pi delta I. So I is equal to 2. 1 and 2. Therefore, your transfer function is C by R into P1 delta 1 plus P2 delta 2. Then our next step is we need to find out the loops. Okay. As per our second step, we need to find out the loops. This is a one loop. Okay, so loop 1 is gain of loop 1 is G1 G4 into H1, and the second loop is here G1 G4 G2. Okay, and then it is coming like this. So G1 G4 G2 H2. This value is going to be negative because this is a minus H2. Okay, then what is the third gain? Third loop is, yeah, third loop is this one. Okay, so G1 G4 and then G3, and next it is coming like this, and minus H2. So then you are coming like this. Okay, so these are the three loops, L1, L2 and L3. Then after getting the loops, then you search for two non-touching loops. So is L1 and L2 are touching to each other or not? Okay, so L1, L2 is touching to each other, and L1, L3 is also touching to each other, and next L2, L3 is also touching to each other. And therefore, there is no possibility of two non-touching loops. And therefore, I can find out these values as delta is equal to 1 minus sum of all individual loop gains only. Okay, because there are no two non-touching loops are available, and therefore we stop here only with the delta value of 1 minus all the values of L1, L2, L3 should be substituted here. Okay, so this will give you the value of delta. Then after that, we need to find out delta 1 and delta 2. Okay, so delta 1 is nothing but delta. So delta 1 is nothing but delta only, but the part of the loop which are not touching to the fast forward path. So this is your L1 and this is L2 and this one is L3. Okay, so the L1 is touching to the forward path, L2 is touching to the forward path, and L3 is touching to the forward path. So this is L1 plus L2 plus L3. So L1 is touching to the first forward path, and therefore it should not be considered. And then you see the L2. L2 is here. Okay, so this is G1, G4, G2, and H2. So this is also touching to the forward path 1, and L3 is also touching to the forward path 1. So this is going to be 0. And that's why your value of delta 1 is going to be 1 only. And next, second forward path. So second forward path, what we have taken here, this is a 1, G1, G4 into G3. Okay, so for this forward path also, your L1 is touching, L2 is also touching with your second forward path, L3 is also touching with the second forward path. And that's why delta 2 is equal to 1 again. Is it clear? And therefore, your transfer function is going to be C by R, which is equal to P1 delta 1 plus P2 delta 2 by delta. So this is the original transfer function. just substituting all the values. Is it clear? No. So we'll solve one more problem here. So anyone, can you tell me how many forward paths are there for the circuit? Again, 2 forward paths. Okay, so the forward path gains are given here, and loops, how many loops are there? How many loops are there? There are 4 loops. Okay, so G2H2, G3H3, L1, L2. So here it has, they are given there, L1, L2, L3, L4. And then how many 2 non-touching loops are there? The 2 non-touching loops, L1, L3, L1, L4. Okay, L1, L3. These two are not touching to each other, and L1, L4 also not touching to each other. So we need to take this one, L1, L3, L1, L4. Next, L2, L3, and L3, L4. So is there any possibility of 3 non-touching loops there? No, 3 non-touching loops. Okay, so 3 non-touching loops are non. And next, now using the above steps, we need to calculate delta. So delta is equal to 1 minus L1 plus L2 plus L3 plus L4. There are 4 loops, and out of these 4 loops, again L1, L3, these are the 2 non-touching loops. Okay, so the formula for delta is 1 minus sum of all possible individual loops plus sum of all possible products of all possible 2 non-touching loops. So this will give you the value of delta. Then after that, we need to find out the value of delta 1. Okay, so delta 1 can be obtained like this. So for the first forward path, delta 1 is nothing but for the first forward path. So first forward path, we are choosing it as a G1, G2, G3, and G4. So we should eliminate this. The remaining loops we need to consider. Okay, so I'm eliminating the first forward path. So how many loops are present now? Out of L1, this is your L1, L2. These two are touching to your first forward path. That's why we should not consider these 2 loops. Only L3 and L4 should be considered. And then you see that these 2 are not touching to each other or not. So here these 2 are not touching to each other. Therefore, L3, L4 is not possible. So only delta 1 is present, and this will be given like this. Okay, so this is the value of delta 1. Next one, we need to consider the second forward path. So this forward path is considered, and for this forward path, L1, L2 are not touching, and therefore we need to include this one L1 and L2, and this value of delta 2 is given by this relation. Okay, so we found all the values. Then as per the Mason's gain formula, your del y of s by r of s is equal to p1 delta 1 plus p2 delta 2 by delta. Okay, just use substitute for all the values, you will going to get the transfer function. Okay, so shall we solve one more problem and close? So are you interested in? So this is the first forward path. And next, only one forward path is there. Just you if you observe this, only one forward path. Next, we need to find the loops. So loop L1 is this one, this point to this point, and next L2. This is a loop L2. This is a loop L3, and this one is loop L4. This one completes. It completes the loop L4. Okay, so this value is G2, G3, G4, G5, G6, G7, G8. So here, this one. Okay, so these are 4 possible loops. And by observing this, there are 3 different loops which are not touching to each other. One is L1, L2 is not touching to each other. And next, L1, L3 is not touching. Okay, L1, L2 is not touching. And L1, L3 is not touching. Then L2, L3. These are the 2 non-touching loops. These are 3 possible non-touching loops. Okay, next we need to see 3 non-touching loops. So 3 non-touching loops are L1, L2, L3. So these 3 are not touching to each other. Therefore, we need to consider these 3 non-touching loops. Okay, L1 is G2H1, G4H2. So here G2H1, G4H2, G7H4. So G7H4. So these are the possibilities of 3 non-touching loops. And next we need to see 4. So there is no possibility of 4 non-touching loops. Therefore, we will close here. So L1, the loop L1, L2. This one is L3, and this one is L4. Okay, and the product of L1, L2. This is L1, L2 plus L1, L3, and next is L2, L3. This two. Okay, so L2, L3. Then minus L1, L2, L3. So here, this is L1, L2, L3. So this will give you the value of delta. Okay, and after that, we need to find out delta 1. Only one forward path is there, so you'll get delta 1 only. And first forward path, this is your forward path. So for this forward path, what are the loops which are not touching? Okay, so this is your forward path. So for this, L1 is touching, L2 is touching, L4 is also touching to this forward path. Only the loop L3 is not touching to this forward path. So we need to consider L3 only. 1 minus of L3. So L3 is given as G7H4 here. G7H4. So we'll represent delta 1 as 1 minus of G7H4. Okay. So with the help of these values, now you can find out the transfer function as, oh, this transfer function is not given. Just you substitute here. So C of S by R of S is equal to P1 delta 1 divided by delta. Okay, so P1 is nothing but G1, G2, G3, G4, G5 into this 1 minus of G7 H4 divided by this total delta. Here, this value we need to substitute. So that is your final transfer function. Is it clear? Anyone, if you have any doubts? So again, just for a few minutes, I will go through this block diagram to signal flow graph also. So if you're getting for a 14 marks, you may also expect this type of problems also. Okay, so you need to convert the block diagram into signal flow graph, and from that signal flow graph, we need to find out the transfer function. Okay, so here for the given transfer function, just we need to take up the nodes. All the nodes we need to take up. So the input R of S, E of S, this one is X1 of S, X2, X3, and C of S. So like this, we need to take up all the nodes. Once you get the nodes, then you join. Okay, so from R to S, E of S, okay, R to E of S, the gain is 1. Yeah, the gain is 1 only. Okay, and next there is a closed path from C of S. So here, this one, from the closed path H3, this value is negative, and therefore you can take up this as a minus H3. And then E of S to X1 of S. So here, E of S to X1 of S, you're having a gain of value G1. Okay, and for this value of X1, there is again a closed path from the X3. So from X3, there is a value of minus H2. So this should be taken H2. And then after that, G2, gain G2 to X2. And again from X2, there is a value of G2 and H1. So H1 will be taken outside from the C of S. So again, this is a minus H1. And then G3 from X2 to X3. And then other value is G4. So this finishes your signal flow graph for a given block diagram. Okay, so we need to consider, remember that we need to consider all the summing points or takeoff points. Okay, or we are call this as a pick-off points. Okay, so these values should be considered as the nodes. Okay, so here R of S, E of S, this one X1, X2, X3, and C of S. So these values should be considered as the nodes, and your gains or block gains will be represented by the arrows in which direction they are connecting, and that value will be represented on the branch. So this will give you complete signal flow graph. Once you get the signal flow graph, then you know how to find the uh, transfer function using your signal flow graph approach. Okay, so here also there is another problem. So R of S, E of S, then X1, X2. Okay, Y1, Y2, just all the values are given there. Then you can directly connect it. Then you'll get the signal flow graph like this. Okay, so for this, there are 7 loops. So all the loops can be obtained, and 2 non-touching loops. Okay, so 4 forward paths. Then transfer function. Okay, so this is about the electrical circuit also. That we have seen. With the help of this equation, we need to draw the signal flow graph. From that, we need to find the transfer function directly. Okay, so this is a block diagram representation. And for this block diagram, these are the two equations for mass 1 and mass 2, where at mass 1 we are applying the force, and we are writing these equations. Okay, so with the help of this, you can represent in a signal flow graph approach again. So with the help of this, you can find the transfer function. Okay, so I will share you all this uh, PDF to you, so you can go through this also. Okay, if you have any doubts, you can ask me. I will share you the recording also, but I need email IDs. సో అందరికీ రావాలి అంటే డైరెక్ట్గా ఈమెయిల్ ఐడి కావాలి. ఈమెయిల్ ఐడి ఉంటే డైరెక్ట్గా మీరు షేర్ చేసుకోవచ్చు, లేదంటే నేను లింక్ ఫార్వర్డ్ చేస్తాను. ఆ లింక్ని మీరు యాక్సెప్ట్ చేసుకోవచ్చు. మీరు ఒకసారి నాకు రిక్వెస్ట్ పెడితే నేను యాక్సెప్ట్ చేస్తాను.